so number 4 here. So we're looking for a function. It's got 2 input variables. Those 2 input variables are longitude and latitude, right? And then there's 3 output variables, and 3 output variables are the rectangular coordinates of that, corresponding point in space. And we're thinking of every point on the surface of the Earth as being a point in an XYZ system, set up with the details like described. Okay. All right. So we want to know X, Y, and Z as functions of L1 and L2. All righty. So let's draw the picture. This is one of the many problems in this course where having a halfway decent picture is really valuable. So take an extra moment if necessary to draw yourself a good picture. I got lucky there, and my circle was good enough. My equator is good enough. Okay, now we need to know the prime meridian. There's the prime meridian. By the way, just a perspective thing, keep in mind I'm looking at this from above the equator, and so that means I can see the North Pole. Right? But because I'm looking at it from above the equator, the South Pole is actually kind of on the back side. Right? So the prime meridian that makes itself all the way down to the South Pole is kind of obscured. It's on the back side of the Earth there for that last little bit, and so I have to go sort of over the horizon there, and then around to the backside. So anyway, just think about that when you're drawing these things. Okay, so there's the prime meridian, and longitude and latitude defined as usual. Let's see here. Let's look at let's get the details right. Our longitude is measured east from the prime meridian. So longitude is measured that way. Right? It's what you might want to call theta. It's the spherical theta, right? Okay. Then let's see, latitude, as usual. Latitude is measured north from the equator, so that's the usual. Now, that means that if I look at, for example, on this meridian here, and if I look at this point, my latitude, L2, it's not phi, but it's related to phi in the sense that phi is that, and so right away you see that phi plus L2 is pi over 2. Is that cool? Yeah. Or said differently, that L2, well, let's do it like this. Phi is pi over 2 minus L2. By the way, we already noted this, but I didn't write it down, so I'm going to use purple to represent L1, and L1 is equal to theta. Okay, everybody happy so far? All right. So now, what about rho? Well, conveniently, all the points on the surface of the Earth are approximately, and for the purposes of this problem, we're going to treat them as equal to the same distance from the center of the Earth, and that is the radius of the Earth, r, which is given in the problem as 3960. So that's my rho. R is equal to rho. Okay, so now if I want to know the coordinates of this point, and let's see here, I want to know the coordinates of this point. That point, I'm going to call it x. It has coordinates x, y, z. And by the way, in this section, conveniently in this section, we have already covered the spherical coordinate section, so we're welcome to use spherical coordinates at this point. And so the very first thing I'm going to do is take advantage of that and write that x, y, z is rho sine phi cosine theta rho sine phi sine theta and rho cosine phi. Everybody remember the spherical coordinate formulas there? Yeah. Okay. All right, now, but this isn't what we wanted. What we wanted was to measure. Yes, I wanted x, y, and z, the rectangular coordinates, right? But I wanted them as functions of longitude and latitude. And that's not what I've written. I've written x, y, and z in terms of rho, phi, and theta. But conveniently, I know rho, phi, and theta in terms of these other coordinates. So, for example, rho is r. Right? And phi is pi over 2 minus L2. And likewise, let's see here, purple. Yeah. Theta is L1. All right, so plug that all in, and let me go ahead and actually do that. And you get 3960 sine of, let's see, phi, pi over 2 minus L2, cosine theta, which is L1, and 3960, sine pi over 2 minus L2 sine of L1, and then 3960 cosine of pi over 2 minus L2. And there we go. Yes?
Instead of like doing sine pi over 2 minus L2, could it be cosine L2?
Yeah, totally. And in fact, that'd be a natural sort of simplification to do. Yeah, absolutely. So and let me just remind everybody here and everybody listening that it is expected and assumed that students know all their trig identities and symmetries and et al. Yeah.
Would that be an acceptable answer?
You'd probably get docked a point if you left it right here. Yeah, just because there is a convenient simplification that can be done, so it really should be done. Yeah. So I'm not going to do it here because it'd take a bunch of time and space, but you guys can do it. Yeah. Everybody happy? Any questions?